In these problems, we are using a model to think about finding the mean of a set of numbers. So you can think of each of these stacks of boxes as being a number. So there are 6 boxes that represents a 6, 8 boxes that represents an 8. I actually made a copy of this over here so I could actually move boxes around because that's what you want to do in this problem. We're going to think about how to find the mean by moving boxes. And really, when we're finding the mean, we're trying to figure out how big these numbers are on average. So we're going to like flatten them out, make them all look the same, and then on average, they're all that big. We're going to do this by moving boxes, and it's pretty simple. You want to go to the highest ones and start moving them to the lowest ones and see if you can make them all equal. So I moved one there, and I think if I move one more here, those will all be equal. It doesn't look right because this one is stacking behind, but that's okay. So we have piles of 6 now. So it looks like on average, these numbers are 6 boxes big, or just on average, they are 6. So that's what the model shows. Let's do the problems here. A said move the cubes so that each stack has the same number of cubes, then give the number. So we figured out that that was 6. And then what is the mean of 6, 8, 5, and 5? Well, I'm telling you it's 6 because that's really how to do that. But let's calculate it how we normally would. We would do 6 plus 8 plus 5 plus 5. Let's see, 6 and 8 is 14 plus 10 is 24. And then we would divide that by the number of numbers, and there's 4 numbers, and that equals 6. So yes, our model and then calculating the mean came out with the same answer. And then C, we just have one little question to answer about this. Are the values you found in parts A and B the same? Why or why not? So the answer to this should definitely be yes. So you can just cross out the no's right away. The tricky part is the why. So we've got 2 yes answers. Let's read them both. The first one says, yes, when we make the stacks equal, the number of cubes in each stack must be the mean of the original stacks. Or yes, but it didn't have to turn out that way. When the stacks are made equal, the number of cubes in each stack may not be the mean. Well, that's wrong. This one here, the first yes is correct. When you do that, when you make the stacks equal, you are getting to the mean of that data set. So if you see this question, it's always going to be yes, they're the same. And if they turned out not to be the same, you did something wrong. And it's because they have to be. Let's try one more of those to practice. Okay. So now we've got 4 stacks of cubes, 5, 6, 3, and 2. And our first problem is to move them so that they're in equal stacks. So let's do that. So they may not stack up on top of each other exactly right, but that's okay. And let's see, this one's now the highest, so we'll move one over here. Now they're all even, and it looks like 4 cubes in each stack. So let's answer our questions. So how many cubes in each stack? That's 4. And what's the mean? Let's go ahead and calculate this. 5 plus 6 plus 3 plus 2. Let's see, 3 and 2 is 5, 5 and 5 is 10, and 6 is 16. There were 4 numbers, so we divide that by 4, and yeah, we get 4. So we did it right. And then C, are the values you found the same? Yes, they have to be. So let's find that one. This first one says yes, but it didn't have to turn out that way. The second one says yes, the number of cubes in this X must be the mean. So that's the one we're going for in C. So that is a little bit of work with using this model to find the mean of a set of numbers.